So in this video, I'm going to be talking about an application of geometric series. So yesterday we learned about geometric series and how to find the infinite sum of one. And it turns out we can use that. We can use the formula S equals U1 over 1 minus R. The sum of an infinite geometric series is the first term over 1 minus the common ratio. We can use that to take repeating decimals and convert them into rational numbers. In other words, to take a repeating decimal and actually find out what the fractional form is that came from. The key skill that we need here is we need to be able to write a repeating decimal as an infinite geometric series. Then we'll be able to take that infinite geometric series, we'll be able to find the first term in the common ratio, and we'll be able to find the sum of that geometric series, and that'll allow us to rewrite it as a rational number. So the first thing we're going to need to do is sort of look at how can we take a repeating decimal and write it as one of these infinite geometric series. So we'll look at that first. And I'm sort of going to do that by just diving into an example. I want to write the repeating decimal, 0.35 repeating, as an infinite geometric series, and then find the sum of the infinite series to write it as a rational number. So here's what I'm going to do. We all know that 0.35 bar means 0.35, 35, 35, 35. So what I'm going to do is I'm going to take this thing and sort of go, well, all right, so this is really 0.35 plus 0.0035 plus 0.00035, and I'm sort of writing this vertically so that we can see, 0.00035. You can sort of see each one of these 35s is just offset by more zeros. If you were to add all these things up, you'd have 3, 5, 3, 5, 3, 5, 3, 5, and so on, right? So this allows us to see that this is an infinite series, right? I'll keep adding this thing up. So the question is, what is the first term and what is the common ratio? Right? Well, the first term seems to be this decimal here, and it's actually going to work really well for us if we can write these things as fractions, right? So this 0.35 is really the fraction, is the rational number, 35 over 100, right? Now, what common ratio is being used? In other words, what's being multiplied to get me from one of these rows to the next row? And what we see is that we're multiplying by 0.01. Right, 0.01 basically moves the decimal point 2 places, but 0.01 is 1 over 100. So that is my common ratio. Right? So what we've shown is that this infinite repeating decimal can be written as this infinite series, which has a first term of 35 hundredths, a common ratio of 1/100th. So that means that I can take my repeating decimal, 0.35 bar, and write it as, the sum of the infinite series. It'll be the first term, 35 over 100, over 1 minus the common ratio, which is 1/100th. If I simplify this, I will end up with 0.35 bar is 35 hundredths over 99 hundredths. I just got a common denominator I made this 100 over 100 and subtracted 1. But at this point, we can divide out, or we can actually multiply top and bottom by 100 to get rid of those, and we end up finding that 0.35 repeating is 35 over 99. That's the process that we use to take an infinite repeating decimal, write it as an infinite geometric series, and then write it as a rational number, as a fraction. The second example is a little bit different, because what we're working with now is we're working with a repeating decimal that's not purely repeating. The 0.2 is sort of like an initial part, and then the 1 that repeats after that. Right? So my instructions here are to write this decimal as the sum of a decimal and an infinite geometric series. So what we're going to do here is we're going to recognize that this thing can basically be written as 0.2 plus, and then the next part will be the repeating part, 0.01 plus 0.001 plus 0.0001. And yeah, I could keep doing this, but we get the idea, right? This red part is the part that's repeating, and this blue part at the beginning is almost like an initial, I don't want to call it an initial value, but it's sort of the initial part of the repeating decimal that we're working with, right? So what I want to do is I want us to figure out what is this repeating part. Let's figure out what that is, and then when we're done, let's add 0.2 onto that. So if you're feeling up to it, pause the video, see if you can work through this part, work through what the repeating portion is, and then check back in, and then we'll add the 0.2 to it. So for this repeating part, the first term is 0.01. You might have thought the first term was this, but remember, that's not a part of the repeating pattern. That's not a part of the geometric series. So 0.1 is actually the first term, and we'd said we wanted to write that as a fraction, so I'm going to do 1/100th. Right? Then, what is the common ratio? Like, what's being multiplied to each term to get me to the next low row down? Looks like we're moving the decimal point one place, which is 0.1, which we could write as 1/10. So my common ratio is 1/10. So the sum of the infinite series is the first term over 1 minus the common ratio. That's 1/100th over 9/10. That's really ugly. It's this sort of super compound fraction. I will multiply top and bottom of this fraction by 100. Is that what I want to do? Not certain of that, but we'll run with it and see where we end up. We'll get S is 1 over... Let's see here. If we'd simplify this thing, you'd have the zeros that would drop here. We're basically going to end up with 1 over 90. Right, so that worked out well enough. Right? We end up with the sum of this thing being 1 over 90. But keep in mind, this is just the geometric part. This is the geometric part. To figure out what our entire expression is, we basically have 0.21 bar. We broke that into 0.2 plus 0.01 bar, and that's the part that we found here. So to get 0.21 bar, we take 0.2, which is 2/10, and I will add that to the 1/90th that we just found. So all I have to do here is get a common denominator. 0.21 bar will be multiply top and bottom by 9. That'll give me 18/90ths plus 1/90th. 0.21 bar is apparently 19 over 90. And you can actually test that. If you take your calculator, 19 divided by 90, you'll find that you do indeed get the 0.21 bar. Okay. So this is one application of geometric series that we can basically use geometric series to write infinite repeating decimals as fractions.